Okay, hi, my name's Al Collins, and this summer I made 3 spiral apparatus for 3 friends, and these are the spiral chucks. Now the spiral chuck, it holds the first gear of the train, and it holds the work, and it allows the work to be indexed without taking the gears out of mesh, and it can be divided anything into 96. So to do this, I had 2 different Rose engines to put them on. I chose front mount spirals so I didn't have to deal with the touch stand, and I made these back plates so I didn't have to drill the headstocks for these guys, and I could drill and tap these holes here to mount the banjo arms. These are the banjo arms. I used existing holes in the headstock to mount these back plates. Now the banjo arms, they accept arbors that hold gears. These are a few of the dozen arbors I made. There's short ones that hold a single gear, and then there's long ones that hold double gears or 2 gears for compound gearing. Now, this is 3 dozen gears I made. They range from 144 down to 15, following the Holtzapfel example, so that the guys could use the Holtzapfel charts in volume 4 to set up their spiral apparatus and pick the pitches that they wanted and like that. Here I have the Banjo Setup, and I'm showing this is all the gears in a straight line, simple gearing. And with simple gearing, only the first gear on the spiral chuck and the last gear, usually on the slide rest, are the ones that determine the pitch of the spiral. But the gears in between, they don't do anything. They're just spacers, and they allow you to put the last arbor where you want it. The only thing it does is, depending on the total number of gears in your train, even numbers reverse the travel, and odd numbers go in the same direction. For instance, well, I'll show it in the next thing here. Here we go. So you can see this rotation and this rotation are the same. That's odd, and here even are opposite. So why that's important, because if you wanted to do like a diamond pattern, you add an arbor and a gear, space it out, and now you can cross over a previously cut spiral. This is an example of compound gearing, and with compound gearing, you use that to get your long, lazy spirals. In this example, we're getting 1 revolution in 7.2 inches, and then I've indexed it with the chuck so that I'm cutting 16 flutes identical, and they all nest together. And let's see what else. Oh, okay, I know. Here's the back side of that same setup, and according to Holtzapfel, you put a 144 here, it goes into a 16 here, with a 120 on the same arbor, that goes into a 15 on the slide rest, and that gives you that 7.2 spiral. Now this gear I didn't mention. Well, this is just a spacer to get this arbor where I wanted it so that it hooked up nice to the slide rest. But it didn't change anything other than change the direction of which way the slide rest was going to move. That's all it changed. It did not change the formula in any way. So it's just a spacer. Now, one of the guys I was doing this for, he had a very short slide rest. And if I put the gear on the slide rest, as is normal, then his slide rest would be locked in this position, and the length of the chuck would take up half his travel. So I took a couple arbors and I bored them out, and I put a rod in it with universals on the end. The rod can slide, and which pushes the slide rest to where you want it, and it'll do the most good, in your work. So that was, and the gear, the last gear, instead of being on the slide rest, would be up here on this last arbor. I realized that using the universals, that it made it very easy to do rocking spirals. And so in my early examples, this is a high count rosette with a single start spiral. And then here's a low count rosette with a 2-start spiral. So it may not be your cup of tea, but I think it bears some looking into, and there's definitely some possibilities there for certain things. Maybe add the curvilinear in there, Now, for the other two guys that had a normal ornamental slide rest, the universals, they posed a problem. They kicked the slide rest too far to the right, and the cutter would not go all the way back to the chuck. So I made these extensions to accommodate that for those guys. It's had threaded nose, and you could put your work holding chuck on, and then it had levelers in the back. So if you had to dial it in, you could. Another example of the rocking spirals. In this case, I'm using an A12 sine wave and a 2-start spiral. That was probably the best piece on the examples that I did. I wanted to include the reciprocator. So I made these 4 reciprocators. The 4th one was for me. The cams have eccentric holes. Each hole is a little more eccentric than the previous hole. And you put the arbors through the holes, and when the cam rotates, it kicks the arm up and back. It connects to these arms that go on the spiral chuck. Here it is set up on the made lathe. And now the takeaway here is that gearing controls the wavelength of, the wavelength. And so the way it works is this wave is 0.8 in length. Now you go here, you got a 10 threads per inch screw, which 1 revolution is 1/10 of an inch. So you take this gear here, which was a 15, and you divide it into this one, which was a 120, and it gives you 8 equal turns. So that's your wave. That's your wavelength. So to further explain it, if you wanted a 0.3 length of sine wave, you would put a 72 and a 24 here, 24 going into 72 3 times. And so gearing controls the wavelength. Now the cam and the eccentric holes, that controls the amplitude of the wave. And so you pick the eccentricity you want, and that controls the amplitude. You can adjust it by moving this arm up or down. Up reduces, and going down increases the amplitude of the sine wave. So here's just a simple sine wave being cut on the made lathe. but you can see the action of the reciprocator right here and how it makes it work. It just rocks it back and forth and you can see the cam doing that. So I found it useful for the guy with the short slide rest, and he had to be able to locate the last arbor in the right place. So I made this dog leg that goes on the banjo arm, and it greatly increased the positions of the last arbor. And in this situation, I used the dog leg again, and that enabled me to hook up this spiral spherical slide rest to the spiral apparatus. So the way it works is the work is rotating, cutting a spiral while it's actually cutting an arc. And here I have a arm rooster Mark II sporting a rocking tailstock and a made slide rest. And the spiral apparatus is set up for compound gearing. So it's cutting a nice long lazy spiral. And it's being indexed with the spiral chuck. And so this summer I made 3 spiral apparatus. Thank you for listening.